Hello, Professor. My name is Yogitha Tekkali. Today, I'll be walking you through my final project on supply chain network optimization. So, in this project, I focused on designing a supply chain model that reduces cost, meets demand, and still that keeps the customers happy. So, going through the introduction, supply chains are really the backbone of the manufacturing companies, but the challenge is always finding the right balance between efficiency and service. To my point, in this project, I use optimization techniques also specifically. The Gorby, which I used as a tool to test how much manufacturing company can streamline the production, also the inventory and the distributions. And coming to the project objective, the main goal for me here is to cut costs, make sure demand was fully met, and explore how the network reacts when things has changing in this real world, like fluctuating demand and also the raising transportation costs. This was my literature review. From my research, it's clear that supply chain needs to be both efficient and flexible. Optimization models like linear programming are widely used to make better allocation decisions. Recent studies also highlight that resilience, sustainability, and digital transformation as the key drivers shaping the modern supply chains. Coming to my methodology, I started with collecting data on demand, production capacities, and also the transportation cost and inventory holding costs. After cleaning and simplifying the data, I created a mathematical model. The objective function was straightforward here, minimize the total cost. Then I coded everything in Python using the Gorby, which solved the model efficiency here. Coming to model implementation, in this model, I included plants, warehouses, and customer nodes. I set constraints to make sure the customer demand was always satisfied and plans that stayed within the capacity. Gorby then calculated the best way to allocate the resources at the lowest possible cost. In the results and analysis part, it is clear that the showed model was allocated by the suppliers to customers in the most cost efficient way. For example, one supplier has handled the cheaper routes while the other supported customers with higher demand. So this way no capacity went two ways and every customer got the same demand fulfilled. So here also we can see that I also tested different scenarios. If demand increased or decreased by 10%, the model still adjusted and met demand. So when fuel costs went up, the model switched to cheaper routes. And in seasonal demand cases, it suggested using more flexible plan scheduling overall. It proved that network was the adaptable way here. So coming to scenario analysis, I also tested different scenarios if demand increased or decreased the same way. So, coming to the sensitivity testing model, to make sure this model was robust, like I ran sensitivity tests when the inventory cost increased, the model shifted toward linear inventories. If the model capacity got tighter, it leaned more on backup plans. So, these tests showed up the model wasn't that fragile here, so it adapted while still minimizing cost. What stood out to me, most of the service levels were never compromised. The model made sure 100% of demand was met, no stockouts, no shortages. At the same time, it avoided wasting resources, so it found a sweet spot between cost savings and reliability. So, in the conclusion, mm, it is the most optimization gave us a much clearer way to plan the supply chain to cut out costs, maintain service, and created a flexible network design. My key recommendations would be to invest in flexible production and transportation, form strong partnerships with carriers, and continuous running scenario tests to stay ahead of the uncertainties. And these are the reference